Here are the notes for 2-1. So the first section here are types of numbers. Real numbers is everything in this box right here. Okay, in this chapter, all we're going to talk about are real numbers. The opposite of real is imaginary, but we don't get to those yet. So from this list of numbers, it would be all of them. Rational numbers. We'll see that word ratio in there. Okay, so that means any number that can be written as a fraction or decimal that terminates or repeats. So, any number, I'll try and write that out, any number that can be written as a fraction. That can be a ratio. Okay, for instance, 2, -2, 1/2, 0.33 repeated, 0, 1 2/3, all of those are a ratio. All right, integers now, no more fractions or decimals. So no fraction or decimal. So that still is 2, -2, no longer 1/2, not pi, not 0.33, not 1 2/3, and 0. Whole numbers. Whole numbers are still no fractions or decimals, but now from integers we get rid of the negatives. So whole numbers are just 2 and 0. My natural numbers are all of your whole numbers, but we no longer have 0. So we call these our counting numbers, okay, because we're starting with 1. So really, our only natural number in this group is 2. All right, so the only one we haven't used yet is pi. So I'm going to go ahead and put that over with irrational numbers. In the next section here, they want us to classify each number in as many ways as possible. And you can check with your answers in the book. So -2.77. Well, it's real because we said all of them are going to be real. It's rational because it's a decimal that terminates. But that's it. It is not an integer because integer has no fractions or decimals. So because I stop there, I can't go any further. Once you say it's not an integer. 178,000. Well, it's real, right? Because it's not imaginary. It is rational. It is an integer. It's a whole number. And it's a natural number. Sometimes students find it easier to start from the bottom and work your way up. In this case, I'm going top down, though. So this one is still real. It's not imaginary. But because it's 020020002000 and these dots mean that it keeps going, it's actually going to be irrational. Okay? In the next part here, we just need to graph on a number line. So -2, that's right here, and that was S. 0.5 would be right here, and that's T. 1 2/3, if you did that in your calculator, 1 plus 2/3, it's 1.67. So then that might be a little bit easier to see. It's in between 1.5 and 2. And then pi, again, if you put pi in your calculator, or maybe you know, it's 3.14. So on a number line, it's going to be close to 3. And we'll just put it right there. The next one are just our properties. Closure. So we start with for all real numbers A, B, and C. Okay? So we have if A and B are a real number, then A plus B, this is the addition column, is a real number. And likewise, if I take two real numbers and I multiply them together, you're going to get a real number. The commutative property, so think commute means to move yourself, like move you, I'm going to say, right? Like you commute to and from school. So A plus B is equal to B plus A. And then same thing for multiplication. A times B is equal to B times A. So it's commutative. Associative, think groups, right? So here we have parentheses that move. So A plus B is in parentheses now. The associative, I'm going to move parentheses and then make it A plus, and then in parentheses B plus C. And then over here, A times in parentheses B plus C. Identity. Well, think about your identity. Your identity doesn't change just because you add your soccer uniform to, what you're wearing. Your identity stays the same. So for addition, 0 is the identity because I can take a number A and add 0 and it stays A. Or if I commute them, 0 plus A is still A. Okay? For multiplication, the identity is 1. So A times 1 equals A, and 1 times A equals A. They're the same thing. Inverse, well, think opposite for inverse, right? So if I have a number A, then the inverse of that for addition is negative A, right? Because if I add A plus negative A, the inverse should give me the identity. So that is 0, which we said here is the identity, right? For multiplication, we have a number A. The inverse is 1 over A. So that I can do A times 1 over A, and I should get the identity, which in this case is 1. The next property is the distributive property, so just distribute the A in, and you get AB plus AC. And then likewise, even if it's last, you still get AB plus AC. All right, so let's practice. On this side, I had 3x, I multiplied by 1. 1 is the identity, so this is the identity property. Okay? Here, I have the identity by itself on this side. I did 2 plus its opposite. This is your inverse. So this is the inverse property. What changed here? Well, it was 2xy, and now it's xy2. So the terms moved, therefore it's commutative. Here I had in parentheses 2 plus x and then plus y outside the parentheses. On the other side it's 2 plus and then in parentheses x plus y. When parentheses move, that means the grouping changed. So that's associative. The next part here is just PEMDAS. So remember your order of operations. These are common mistakes students make. If you have -1 in the parentheses and that's being squared, that's -1 times 1, which is 1. In this case, this is negative, and then you got it 1 times a 1. So it's just multiplication. Negative distributed to the first one is -1. -1 times 1 is -1. Okay, so see the difference? You really need those parentheses. And then here, you got to do multiplication first. So this becomes 8 minus 6, which is 2. Here, you got to do parentheses first. 8 minus 2 is 6, and then times 3, which is 18. If you type this in your calculator like that, it will know what to do first. However, this one, you would need to put in parentheses, because 2 plus 3 is all in the numerator together, and then 4 plus 6 is on bottom, so that's 1/2. When you're adding two fractions, they have to have a common denominator. I noticed first that they can both be reduced. 2/4 can be reduced to 1/2. 3/6 can be reduced to 1/2. Now that they have a common denominator, add your numerators and keep your denominator. It's 2/2, which is just 1. Or you could let your calculator do the work. PEMDAS says, like in the order, it looks like multiplication comes before division, but really, if you have both in one, just do whatever comes first. So first I need to do 100 divided by 20, and that's 5, and then times 4, and that's 20. Okay, this one I have in parentheses. So the 100 stays, but in parentheses, that has to be done first. So 100 divided by 80, which might be easier to write it like a fraction, and then you can just reduce it. Right, so these are going to cancel, and the 10 can become a 5, the 8 becomes a 4. And you're done. All right, we've got one more, or I guess two more down here at the bottom to do. So we do exponents here. 2 squared becomes 4. In parentheses, 12 plus 8 becomes 20. And then on bottom, you've got 5. So 4 times 20 is 80, divided by 5 is 16. You can always check on your calculator, but you want to show work because it will be multi-point questions on a test or a quiz. The next one is multiplication first, so 18 minus 10, and then 15 minus 9. 18 minus 10 is 8. 15 minus 9 is 6. That reduces to 4/3. So those are all of the notes. Be sure to do the homework from the textbook.